Hello, thanks for joining me today. We're going to talk about estimating and order of operations. So we'll start with estimating, and we've already talked about how estimating can be helpful to us in checking to see if we got the answer right. Today we're going to estimate on purpose. So we're going to get an answer that is an estimate. And we'll see the value of it, and we'll see when it is a little bit can there can be some problems with it. So, for example, 7.3 minus 3.8. It would be a lot easier to round 7.3 down to 7, and 3.8 is closer to 4, and 7 minus 4 is 3. And we could say, well, the answer is close to 3. Now let's do the real problem and just check and see how that estimate worked for us. So we're going to subtract. We'll borrow from the 7, make it a 6, and carry the 1. 13 minus 8 is 5, and 6 minus 3 is 3. So the real answer is 3.5, 3.5, and our estimated answer is 3. So it's close, but understand it's off. So estimating can get your answers off. Now let's do another example. The easiest way to do this, if I was going to estimate this next problem, 98.2 times 405.8, if I was going to do this in my head, I would estimate it to the nearest hundreds place. So I would just do 100 times 400. And that's easy. That's 40000. So 4,000. I just add 4 times 1 with 4 zeros. 40,000. That is the estimated answer. Let's give it a try. Let's do the real answer. 405.8 times 98.2. So let's see. 2 times 8 is 16. Carry the 1. 2 times 5 is 10, plus 1 is 11. Carry the 1, but 2 times 0 is 0, plus 1 is 1. 2 times 4 is 8. Bring down a 0. 8 times 8 is 64. 8 times 5 is 40, plus 6 is 46. 8 times 0 is 0, plus 4 is 4. And 8 times 4 is 32. Okay, last number, 2 zeros. 9 times 8 is 72. Carry the 7. 9 times 5 is 45, plus 7 is 52. 9 times 0 is 0, plus 5 is 5. And 9 times 4 is 36. And I'm almost out of room here, but we'll bring down to 6. 6 plus 0 plus 0 is 6. 4 plus 1 plus 0 is 5. 6 plus 2 plus 1 is 9. 8 plus 2 plus 4 is 14. Carry the 1, 5, 6, 7, 8. 3 plus 6 is 9. And then that 3. And there's 2 decimal places, 1, 2, so we'll move the decimal point over 2 spaces. So our real answer is 39,849 and 56 hundredths. So our estimate is off by about 200, maybe 150, a little bit more than 150 off. So it's pretty good. Out of 40,000, 150 off. So that estimate, obviously it took a lot longer to do all this work than it did to do this work. I had to write this long one on paper. The estimating I could have done in my head. So there's some real value to estimating, but understand most of the time in math we want the actual number, the actual numerical answer, not the estimated answer, because most of the time we're going to do something with our answers. But in today's lesson, you get to do some estimating. Be careful to follow the directions. We're going to estimate again. We're going to divide. Now, when we're dividing, it's helpful to kind of think about how many times will this number go into that number, like how can we get it to go in evenly or kind of the most simply. So I'm going to, of course, take 24.9 and I'm going to round it up to 25. So that's going to be 25. But then I'm going to say, instead of just automatically turning 186.75 into 186 or 87 or 190, I'm going to say, well, if I'm counting by 25s, then the closest number to 186.75 would be either 175 or 200. So 175 or 200, and 186.75 is closer to 175. So it might be wise to think about it that way and say, well, I'm going to round this to 175. That way, 25 goes into 175, and we can just do this on our fingers, right? 25 goes into 100 4 times, and 75 3 times, so it's a total of 7 times. And so the answer is 7. And I didn't have to do it on the board. I did it on the board just to kind of show you, but we definitely could have done that just mentally, just counting by 25s or thinking about 25 being quarters and how many quarters are in 175 pennies. Okay. If I wasn't taking care, I might have said, well, 24.9 is going to round up to 25, and 186.75 is going to round up to 200. And if I'd done that, then I would have got an answer of 8. So somewhere between 7 and 8 is probably what my answer is. Let's do it real quick, just for curiosity's sake. 24.9 goes into 186.75. We'll move the decimals over, so I'll just move them over one space. Just do them in blue so they're easier to see. Okay, 249 goes into 186 0 times. 249 goes into 1,867. Now let's see. Probably 8 times. I'm going to guess 8. I'll do it over here. 249 times 8. Let's see. 8 times 72. 32 plus 7 is 39. 1619. Oh, I was wrong. It's not 8 times. It is 7 times. So 249 times 7. 7 times 9 is 63. 7 times 4, it's 28, plus 6 is 34. 7 times 2 is 14, plus 3, 17. So 1743. 4 squished over there. That is, and I changed my mind. Instead of 8, I'm going to say 7. Okay, and I should have known this. 7 minus 3 is 4, 6 minus 4 is 2, and 8 minus 7 is 1. And now the question is, how many times does, we'll bring the decimal up, how many times does 249 go into 1,245? And I'm going to say 5 times, maybe. Oops, 249, I don't need the decimal point, times 5. That's 45. It's 24. That's 12. Oh, look at that. So the real answer was 7.5, and notice that's halfway between my two estimates. So if you're thinking about this a little bit more logically and carefully, you can come up with answers that are close to the correct answer, or you might come up with an overestimate and an underestimate, and in this case, the real answer is directly in between the two. Okay, let's move on to a word problem here. The side lengths of a triangle are 5.7, 9.8, 12.4. Estimate the perimeter by rounding each measurement to the nearest whole foot. So I'm going to take each measurement, round to the nearest whole foot. So this is going to be 16, this is going to be 10, and this is going to be 12. Okay, so I rounded up twice and down once, and this is now really easy to add together. 38 feet. And so we might use, I like to use this little squiggly equal sign, approximately 38 feet, just to let people know that we use rounding. I've seen an equal sign with a dot on it to show that we use rounding in the answer. So that is how we would do this one, and I'll leave it to you to do the real work of addition here and see how far off we were. Okay, now, second thing that we want to look at today is order of operations. And we've talked about order of operations, remember the PEMDAS. And the main thing for us is going to be multiplication before addition. So multiplication and division before addition and subtraction. So here we have 8.2 times 100 minus 8.2 times 10. So we're going to do the multiplications first, and then we'll do the subtractions. So 8.2 times 100 is 820. We just move the decimal over 2 spaces whenever we multiply by a multiple of 10. 8.2 times 10, move the decimal over 1 space this time, 82. So 820 minus 82, that's going to be 8 and 3, so 738. You can do that subtraction on your paper. I know you know how to do that, so I'm not going to demonstrate that one here for us right now in the interest of time. Let me show you the next problem, and I want to show you a different way of presenting it. If I had 0.707 minus 3.19 over 13, this is a subtraction problem, and it's a division problem. And I use, instead of the division sign, I use the division bar. But remember that the division bar, the fraction bar, is also implies a grouping symbol. So you do whatever's in the numerator and you do whatever's in the denominator, and then you do the division last. And that's what we're going to do here. So we're going to do 0.707 minus 3.19. The way that I do this, I don't know if I've shown you this before, 3.19, and then I'm going to put 0.707, and I'm going to subtract the smaller the number with the smallest absolute value. So 0.7 is smaller than 3.1. So I'm going to subtract in that order, but I know that the answer is going to be negative because I'm subtracting a larger number from a smaller number. Okay, so now let's do the subtraction here. So we're going to borrow from the 9, make it an 8, carry the 1, so 10 minus 7 is 3, 8 minus 0 is 8, 1 minus 7, nope, not big enough, so we're going to borrow from the 3, make it a 2, make that 11, minus 7 is 4. Bring down the decimal points. Remember, when we're adding and subtracting, we have to keep those decimals lined up. And then 2 minus 0 is 2. And remember that the answer is negative, so negative 2.483. Negative 2.483 divided by 13, and now we can do that division. Now, I'm not going to write the negative sign in here, 2.483. I'm just going to write in the spot where I'm going to put the answer, I'm just going to say negative, so that I know that this is a negative answer, but I'm not going to write that down here. Okay, so 13 goes into 2, 0 times. 13 goes into 24. Well, let's see, 2 times would be 26, so no, it's just 1 time. Subtract 13 from 24, we get 11. Bring down the 8. And 13 goes into 118, probably 8, 9, let's see. Let's try 9 times, we'll see. So I'm gonna do off the side. I'm gonna do 13 times 9 is 27. 9, 10, 11. Oh, look, it worked. Oh, and it. Hold on now. Yeah, I think I got my numbers mixed up. I wrote 72 instead of 27. So this should be 7 there. And we're going to subtract 118 minus 117 is 1. Bring down the 3. And let's see, that was 9 times. So then 13 goes in 13 one time. And we have our answer. It's negative 0.191. Now it's important to recognize that decimal answers don't always have to come out nice and neat and terminating. We call these terminating decimals where they stop. We don't have any more answer going on here. It's just a bunch of zeros. But you shouldn't expect that that's always going to be the case, but it turned out that way for this problem. Okay, finally, we've got a couple more down here. Let's see, we'll do 2 more. Let's do one more order of operations problem. This one is more explicit. We have a grouping symbol. This parenthesis is saying do the subtraction inside before you do the multiplication outside. So we'll do the subtraction. 5.6 minus 6.5. Notice again we're subtracting a large number from a small number, so when I do the long subtraction, I'm going to write 6.5 on top, 5.6 on the bottom, but I'm going to remember that the answer is going to be negative. So subtracting here, borrow from the 6, make it a 5. 15 minus 6 is 9, so there's a decimal point, 5 minus 5 is 0. So it's negative 0.9. And then I'll bring down the multiplication. 0.9 times negative 0.9, of course, is negative. A positive times a negative is negative. 0.9 times 0.9. Almost don't need to do this. 9 times 9 is 81. 9 times 0 is 0, plus 8 is 8. And of course all the zeros. So then we're just going to go over 2 decimal places. A decimal point there. Negative 0.81. Okay, finally, this I thought was an interesting question. We do know how to solve this equation, so we could solve the equation 5y minus 8.6 equals 23.9. So we could solve that equation using the normal steps, adding 8.6 to both sides and then dividing both sides by 5 to see if 6.2 is a solution. I want to show you a different way to do that. It's this. I can take 5, and it says 5 times y, so I'm going to write times y minus 8.6 equals 23.9. And in the spot where the y was, I'm going to replace it with 6.2. And that's the point of this solution sentence term here. Solution just means is 6.2 a value for y that makes this sentence true? And we'll find out by, instead of solving the equation, we're going to find out by simplifying the left-hand side and seeing if it matches up with the right-hand side. So 5 times 6.2, 5 times 2 is 10, carry the 1. 5 times 6 is 30, plus 1 is 31, and there's 1 decimal point, so 31.0 minus 8.6. I can't do that one in my head. 31.0 minus 8.6. We'll borrow from the 1, make it a 0, make that a 10. 10 minus 6 is 4. Bring down the decimal point. Again, we'll have to borrow from the 3, make it a 2. So we have a 10 there. It's 2. And then 2 minus 0 is 2. And so 31.0 minus 8.6 is 22.4. Does that equal 23.9? Well, if we were estimating, chances are we would have said yes, but precisely no. The answer is no, and therefore this is not a solution. Well, thank you so much for watching, and enjoy your efforts in pre-algebra today.